Hey everybody, I'm going to make you a video based on the prep for periodic table. Okay, I am going to walk you through each of the questions, try to break it down for you. And I'm actually going to try something new. I don't know how often this is going to happen, but I do experience this, so I know it should happen some. A lot of times with Regents exam questions, you can actually play a game where one of these things doesn't belong, three of these things kind of match, and that one thing that doesn't belong is your answer. So I'm going to kind of try and do that and go through the actual answers first, then go back and reread the questions again, and then see if it works. We're going to kind of experiment, but at the same time, I'll be breaking these questions down for you so you really understand how to decode these questions. So it says, which element is a solid at room temperature? I'm thinking phase right off the bat. Solid is one of the particular phases. I asked you to memorize the phases by first memorizing the two liquids and then the few gases, and then everybody else is a solid. And we just happen to be looking for a solid. Neon is a noble gas, so that's a gas. Mercury and bromine are my two liquids. And you can see now that three of these things kind of match, except for they're not all three liquids. They're just all three not solids. So iodine is my solid. Going back, which is solid at room temperature. Room temperature is just another word for standard temperature and conditions. And here we go, we got it right. Okay, moving on to the next question. Let's see what it says. It says, the metalloids that are in group 15 are SB and something. So group 15 is right here going down. And I know that right off the bat, N is in group 15 and P is in group 15 and AS is in group 15 and BI is in group 15. So they're all in group 15. So now I need to figure out which one is a metalloid. And I know the metalloids are the ones touching the staircase. So that's going to be AS and SB. And the only one there that is not AS or that is AS or SB is AS. So that is a definition question. Do you know how to find the metalloids? Okay. Moving right on because it's going to be 20 questions. I don't want this thing to take 2 hours because I want you to be able to watch it and use it to study. Okay. Two forms of solid carbon, diamond and graphite, differ in their physical properties due to their differences in. Okay, so right off the bat, solid carbon, different properties. So this is kind of the definition of allotrope, is what I see. So I'm looking for what's going on with an allotrope. Which ones of these things I can put in there? Well, if an allotrope is all the same element, so it does not have different atomic numbers. Isotonic abundances is what we use to get the average atomic mass, the different abundances of each isotope. So that's not it. Percent compositions, it's all carbon, so it's 100% carbon. That leaves me with crystal structures, which is what we knew about allotropes. We knew allotropes was same element, different physical arrangement in space. That would be the crystal structures. Okay. Moving right along. On to number 4. Atoms and elements of group 2 all have the same what? Okie dokie. So atomic mass. I'm going to look down group 2. If I forget, I see the word group and then 2. I'm going to look down group 2. Let's see. Beryllium has a 9.0 and magnesium has a 24 for mass, so they don't have all the same mass. Atomic number, I see 4, 12, 20. They don't have the same atomic number. Atomic number is the same as number of protons. Number of valence electrons, I see 2 for beryllium, 2 for magnesium, 2 for calcium. That is my correct answer. Number of valence electrons. And if you know the definition of families and atoms, what makes an atom act similarly, then this would have been a way to go through that question a little bit even faster yet. Okay, that is by definition of what a true family is. Which element is classified as a metalloid? We know that the metalloids are touching the staircase above and below. So I'm just going to hunt them down and see who is touching the staircase. So sulfur S, not touching the staircase. Silicon Si, yes, touching the staircase. I'm going to continue just to make sure. Barium is Ba, way down here, no. Bromine, Br, way over here, no. Answer is obviously silicon, touching the staircase, straight up definition question. This is one that could, as long as you know to look for the staircase, 3 of these things don't belong and 1 does. Okay? But it is kind of loose. You'd have to know the staircase. So I'm having trouble finding any ones yet that are exactly perfect to 3 things, are going one way and the other one's going the other direction. But we're good there. We're just going to keep it in mind that it can happen. Once we get to the whole course, I think we'll see more of that. As elements in period 3 are considered an atomic number, what a general decrease in. So which of these things is going down? Well, this is something, honestly, on the test, you might have to look up if you don't know. Okay, but so period 3, so I'm going to pick Na, which is element number 3. And I'm going to pick Cl, which is element number 17. Okay, well, their atomic masses. It's going from 23 to 35. So is that decreasing? No. Okay, atomic radius. I'm going to look them up. Oh, well, I screwed that all up. Period 3, Na is not 3. Na is 11. Sorry. I got silly. I did lithium with all of our examples during class, so I was excited about using lithium again. Sodium's atomic radius is 160. And 17, see how I wrote these numbers down? It's easier to look them up that way. 17 is 100. Oh, look, that is actually decreasing, but I'm going to do due diligence, make sure I check the rest of them. I'm going to just check out the same numbers, right? So 11 for electronegativity is 0.9, and 17 for electronegativity is 3.2. Oh, that is definitely not decreasing, that's getting bigger. And then first ionization energy, sodium is 496, and chlorine is 1,251. That again is increasing, so now I know my radius is decreasing as I go across. Goes fast if you have the trends memorized, but you don't need to, just look them up. Okay? Just look them up. Write down a few numbers and you get that answer right every time. All right, almost halfway there. Noble gas. Noble gas means it is in group 18. So I could just ask you which of these are in group 18. Hydrogen's in group 1. Oxygen is in group 16. Nitrogen is in group 15. Neon is in group 18. There's my answer. I need to know the definition of noble gas is group 18. Again, another definition question. So I have a feeling that this unit you can really boil down to definitions. Okay? Moving right along. Which element is in the halogen family? I need to have memorized that the halogen family is group 17. Potassium is in group 1. Boron is in group 13. Iodine is in group 17. Sulfur is in group 16. 17 matches up right there. There we go. That's how we get that right answer. And yep. Let me get rid of this thing so I can hit that. Boom. Got it right. Next one. Moving right along. Which statement describes the general trend in electronegativity and first ionization energy? Oh my God, this is going to be a lot. You just feel it right off the bat. See all the words? You just feel like this is a lot. You're right, it is a lot of work. In period 3, from Na to Cl. So again, that's element 11 and element 17. And my board's being a little funky, so let me just recalibrate it. look those things up. What's nice is I only have to look up 2. So let's see if my 17 can come out any prettier. Oh, good. So I'm just going to look them both up. Okay? So for sodium, number 11, I have first ionization energy of 496 and electronegativity of 0.9. So this is my electronegativity, and this is my first ionization. And then for element 17, I have 1,251 and 2.6. Oh, that's the wrong one. That is sulfur. That's 3.4, 3.2. That's okay, 3.2. So as I go, my first ionization energy increases. My electronegativity increases. So they both increase. So which one shows that they both increase? It's just a matter of writing them down and having a smart board that doesn't go crazy and give me wiggly numbers, and we'd be all set. So they're both increasing. So here's an answer that says they both increase. Let's try it. And we were right. So notice we just had to look those ones up. That's one of those look it up questions. There's going to be a lot of look it up questions on this test. So please do due diligence. Know your definitions. Due diligence. Look them up. Okay? When that happens. So which group contains elements in all 3 phases? Ooh, this was a little tidbit. I told you. So this is group 17. Group 17 has gases up top, bromine's a liquid, and iodine and AT, is that antimony, is the solids. Group 17's name is halogens. That is a definition question also. You need to know that kind of information. We talked about it in class. I know it was part of a POGL or part of one of the practices. Which element is an alkali metal? Alkali metal. This is alkali, one word, group 1. So we just look them up. Hydrogen is in group 1. Calcium is in group 2. Sodium is in group 1. Zinc is in group, 12. So calcium is out, zinc is out. I have 2 group 1s to make you think. And then this is where we had to remember from the reference table quiz that hydrogen is not a metal. It says group 1 metal, so that is sodium. That one's tricky. Really make you think because 2 group 1s were there. Okay? 2 group 1s were there. Okay, next question. I don't know why it's doing that, but here we go. Which element has chemical properties that are most similar to fluorine? Fluorine is element number 9 in group 17. And so if I am going to have similar chemical properties, I need to be the element above or below so I have the same number of valence electrons. Okay? So I'm going to look up fluorine's element number 9. Boron is element 5, which is way over here. So that's not it. Chlorine is right here, 17. So that's right next to my 9. Neon is right here to my fluorine. So that isn't going to cut it. And then oxygen is right here. So 3 of them are actually close to my fluorine, and one of them is way off. But this one, we have to know by definition, it has to be in the same group. That way it has the same number of valence electrons to give me chemical properties. Okay. So far, 3 of these things, I've not seen any of those things I led with, but I'm going to keep going with that that theme for the year because I want to try to identify those when we can. All right. To which group do alkaline earth metals belong to? Okay. Well, we did alkaline. We did alkaline earth. 2 words. Group 2. Okay. So, group 2. Got it. By definition. So it's a definition heavy unit, guys. Definition heavy unit. Need to know all those things. So we had to have all those terms memorized. Which list of elements contains a metal, metalloid, and non-metal, and a noble gas? Oh my goodness. Okay, so let's do metals in red. Metals are left of the staircase. So NaZn. As is a metalloid. Okay, Ke FeB is a metalloid. Carbon, nope, those are all nonmetals. Be is a metal. All right, so there's all my metals. We do metalloids now in green. So Si is touching my staircase. None of these are touching my staircase. Boron is touching my staircase. And As is touching the staircase. And then noble gases in blue. Oh, wait, nope, nonmetals. So chlorine's a nonmetal. Carbon, nitrogen is a nonmetal. Fluorine is a nonmetal. Sulfur is a nonmetal. Then in black would be my group 18. Oh, there we go. And then here we go. Oh, there we go. So which one has one of each? Answer A. Moving right along. So we need to have all of our families memorized. Elements in group 2 have similar character properties because each has the same valence electrons by definition. We just did this in 2 problems ago. It was just done differently as which element's going to act the most alike because they have similar chemical properties was in both of those. So I know chemical properties is valence electrons by definition. So this one's even easier. It's straight up a definition question, not an application of definition, which is what the first one was. Which general trends in first ionization energy and electronegativity are demonstrated by group 15 elements as they are considered in order from top to bottom? Okay, well, I'm going to have to pick 2. It's going to be another one of those look it up questions. Group 15 from top to bottom. So I'm going to pick nitrogen, which is element 7. And I'm going to pick Bi, which is element 83. And I'm going to look up the 2 things, first ionization energy and electronegativity. So for element 7, I have 1402. And my smartboard's acting funny again, but it makes noises when I recalibrate. So, oh my gosh, that's supposed to be 3.0. See if it just writes better on the other side. I bet it does. 1402 and 3.0 is my electronegativity and my first ionization energy. And then for the other element 83, I have 703 and 1.9. So this is going down and this is going down. Look it up. They both decrease. So I just picked the answer that says they both decrease. This is a straight up look it up question. They both decrease. So decrease, A. Got it right. You know, when I get one of these wrong, y'all are going to laugh at me, right? If I get one wrong, if I read too fast or something. Compared to the atoms of nonmetals, atoms of metals in period 3 have fewer electrons, valence electrons. Well, is that true? Let's look. Period 3's nonmetals have 7, 6, 8, 5. Period 3's valence electrons have 1 or 2. So that is true. They do have different valence electrons. More valence electrons, no, we just disproved that. Fewer energy electron shells or more electron shells, they all have the same number of electron shells because I know the definition of period. Going across the period, they all have the same number of energy levels or electron shells, same word. So it can't be this or this because those are the same. So it's either fewer valence electrons or more. If I read it correctly, let's double check. The atoms of metals have fewer valence electrons than nonmetals. So I think I read it right. Oh, phew. Ooh. Sweet, 3 more and we're done with this. Which statement explains why neon is in group 18? Okay, so everybody in group 18 is a gas. That's true. That is true. Neon is a gas. Are there any other gases, though? There are. So we know nitrogen, oxygen, fluorine, and chlorine are gases, and hydrogen are gases. And they're not in group 18, but that is a true statement. It has a low melting point. I don't know. I'd have to look that up. Neon is element number 10. Melting point is on here. Element number 10's melting point is 24 Kelvin. That is a super low melting point. It does have that. These are all true statements. Neon atoms have a stable valence electron configuration. Oh, it has 8 valence electrons. This is true. And neon atoms have 2 electrons in its first shell. Mishka. These things are all true statements. But here's the key thing. Why is it in group 18? Let's check it. Basically, everybody other than hydrogen and helium start with two electrons. So that doesn't make it special. Okay. Low melting point, there's lots of them. Neon is a gas, there's lots of them. The correct answer is stable valence electrons. Everybody in group 18 has 8 valence electrons, except for helium, who has 2, which means they have full valence shells. So the key here is full valence shells, which is answer C. We right. So we need to know, again, definition of our families, which makes noble gases. Helps me answer that. Definition of noble gases, full valence shell, not reactive, they're very snooty. Which elements have the most similar chemical properties? This is the 3rd time I've seen similar chemical properties. Similar chemical properties mean they're in the same group, which hence they have the same valence electrons. So I just need to see who here is in the same group. Si-As-Te. No, those 3 are going down the staircase. They are all metalloids, but that doesn't mean they're necessarily similar in chemical properties. Nitrogen, oxygen, fluorine, all diatomic, but they're going across. Okay, so I got 1 on a staircase, 1 going across. Mg, Sr, and Ba are all in the same group, so this might be it. And Ca, Cs, and Cu is all over the place like this. So the answer, these guys are all in the same group too. So C is my answer. Knowing the definition of similar chemical properties lets me know I have the same valence electrons, hence in the same group. That was on here 3 different times. Which general trend across period 3? Okay, so which general trend across period 3? I know that their atomic radius increases or decreases. You have to look it up. It actually decreases. So that's a winner. It does not increase. Increasing electron negativity. Ooh. Look it up. So let's period 3. Na is 11. Chlorine is 17. Due diligence. First ionization energy, 496. And electronegativity, 0.9. And radius was the 160. And group 17, I got 1, 2, 5, 1. 3.2. And radius is 100. So, which general trend is found as elements are considered in order of increasing atomic number? Well, the atomic radius right here definitely decreases, so that could be a winner. Increasing electronegativity, ooh, that happens. Decreasing first ionization energy, ooh, that is definitely not happening. So, I'm sorry, I'm reading this wrong. See, it says decrease. This is where I want to model for you what would just happen in my head. I just had 2 answers that were potentially right. I was like, wait, increasing electronegativity, that definitely happens right here. And increasing atomic radius happens, but I was not, mass. I thought both of them were atomic radius, but I had 2 check marks as possible right answers. So when that happens, red flag, something's wrong. There's 2 potential right answers. I misread something, most likely, or I made a common silly error. So in this case, I misread and made a common silly error. Luckily, I didn't pick it yet. I see my electronegativity is increasing, and I'm looking for increasing, so we're good. And with that, we finished, and we are done decoding the prep for periodic table. I hope this helps you guys study for the test, and I will try to make more in the future.